Good afternoon and welcome. My name is Mike Neville-O'Neill. I'm a senior product manager at New Relic on the logs team. Today I'm joined by my co-presenter, Kayla Reopelle, who is a senior software engineer on our open source agent team for the Ruby agent in particular. And today we're going to be spending a bit of time talking about APM, logs, and context, unsurprisingly. But before we get into the specifics of the features and functionality that we released earlier this month, I want to give you a brief introduction to New Relic so that you can get just a quick understanding of who we are and what we do. Next, we'll move into how it actually works and the work that we ended up doing to actually build the features and functionality that we'll be demoing closer to the end of the talk. So what is New Relic? I think it makes sense to think about New Relic in terms of the customer problems that we try to solve, where what you see here today is a software monitoring architecture which is reasonably common. In fact, this is the observability architecture of a customer we worked with before they migrated to New Relic. And so what causes what we're looking at right here? Essentially, there's been an explosion in data over the last couple of decades, an explosion in technologies and platforms that developers and engineers are responsible for maintaining and working with. And what has come along with that explosion in data is an explosion of tools that can be used to ingest, manage, and get analytics from that data. As a result, what we found is that software teams have often been forced to adopt a fragmented monitoring tool set for their infrastructure versus applications versus logs versus digital experience, AI ops, and on and on and on. And this leads to a couple of interesting consequences. The first of which is there's no real single source of truth that exists in an environment like this. What you have to do is consult a number of different tools to try to cobble together or to synthesize a picture of what's going on in your environment. The second interesting consequence of this is all of the time that you end up having to invest in synthesizing that picture. It's not something that's easy to do, and there's a lot of friction as you switch context from tool to tool to try to get a comprehensive view of the health and status of a given environment. The average organization at this point has dozens, if not hundreds, of disparate tools that are used to monitor different parts of their technology stack. So what we've heard from our customers, from our developers and engineers, is that they were looking to put their customer and operational data in the same place. Hence, we built the New Relic platform. So we spent 2 years working with our customers to understand how we could build a platform where they could centralize that customer and operational data. And what we end up doing is taking all of your telemetry data and we ingest it into a single open data platform where metrics, events, logs, and traces from any source can be observed, both separately or together. We also have machine learning baked into every element of the platform so that teams can detect, understand, and resolve incidents faster, reducing alert fatigue, and being more proactive and data-driven. And lastly, we wanted to allow our customers to easily visualize and troubleshoot their entire software stack in one connected experience. So without that need to be switching context from tool to tool to tool to see what's going on in your environment. So with that, we can get into APM, logs, and context, now that we've explained a little bit about New Relic and what it is that we do in the observability space. And I want to start with kind of a specific problem to logs, since we've covered the higher level customer problems that we're looking to solve. But I think with log data, there are really two key challenges that are always present. It's collection and correlation. How do you get that log data out of a source or a given environment into a destination of your choosing that we hope is New Relic, but it could be another? And the second question is, how do you actually ensure that that data is correlated? How do you make sure that it is meaningful and useful to you once you've ingested it into a platform? And how can you ensure that it's going to be available when you need it and where you need it? So we really approached this entire APM logs and context experience with those two problems in mind. And for the correlation piece of it, we ended up building the logs and context component that connects application logs with transactions. And all of this is done automatically. Essentially, what we're able to do is to inject span or trace IDs into the logs themselves, so that you never actually have to run a query to find the logs that are associated with these transactions or spans or traces. You'll never ever have to try and figure that out or run a query for something that the platform knows out of the box. So all of that work is done for you. In addition to the enrichment capability, we also added the ability to forward logs directly from the APM agent. So what this means is it doesn't require any sort of domain expertise or access to the underlying host or environment to configure a dedicated log forwarder. The individual developer is empowered to choose the data that they want to send to make their investigations easier. We've also automated that enrichment process. So what we saw in the last slide, that enrichment and injection of span and trace ID into the logs, there is zero configuration required to get that up and running, as Kayla is going to show you in just a few minutes. You get up and running very quickly and replicate that experience. And lastly, we enhance the UI to place log hooks around various elements and features to make sure that the log data was always going to be available to you when you need it if you're investigating a trace or an infrastructure issue or another issue. At the moment, you can see our supported languages and frameworks, which are starting earlier this month. So we support Java, .NET, Ruby, as well as Node. And coming soon will be Python, Go, and PHP. So with that out of the way, I'd like to turn things over to Kayla, who's going to run you a bit through how we built it and give you a quick tour of the product. Thank you, Kayla.
Thanks, Mike. Hello, everyone. So how does this feature work? To talk about that, I'm going to go over a little bit about how we run the Ruby agent and instrument new features, and then we'll give a quick demo of the product to see the data in the UI. So when we have a new piece of code that we want to instrument, or really a new library we want to instrument, we try to find the common place where all of the events that we want to capture will flow through, and all the necessary attributes and data will be accessible. Hopefully that'll be within the same method. Sometimes it might need to be within a few methods. But we're really fortunate in Ruby that the logger class that's built into the language is actually what the majority of the libraries will use to log the messages that you see. So that's where we decided to put our code. So let's look closer at the Ruby logger class. Right here, this is a bit of an overview in case you haven't used the Ruby logger before. You can start out by calling logger.new and defining where you would like to output your log messages, sometimes to a file, sometimes to standard out. You can also call by severity, logger.info as an example here. And the Rails logger uses this class as well and looks very similar, where you just call Rails logger debug to get your logs output. So under the hood, how does this actually work? So when you call that logger.error, what is actually happening is this method right here, and it's calling another method called add and passes just an error constant to it as the first argument. So let's take a look at add. This is kind of the next layer. We're getting closer. Inside of add, it does a lot of different checks. But we ultimately decided that this wasn't the method that we wanted to use to instrument, but the method we instrument is inside here. So taking a look at this code, I don't know if anyone can spot what we ended up using. We ended up using format message, which is right at the bottom of this method. And what was unique about format message is that it actually formats the severity. So this is a little bit of a detour, but the format severity is, it's taking severity, which at this point has still been an integer, which is a little easier to store, and also allows us to have severity levels, where we start with debug that has level 0, and then fatal, which has 5. And we can organize things that way, and that also allows us to cap our logger by a certain severity. So you can only see messages higher than a certain value. So now that we have format severity there, what is calling format severity is format message, and that's what we ultimately instrumented. Because it's called every time a message is logged, it receives the severity translated into words, which was one of our desired attributes, and receives the message in its final formatted state, which was our other desired attribute. So now we can head into the Ruby code that we have inside of the agent. And so this is a file that looks really similar to the other files that we have in our instrumentation. It's a little bit silly because Ruby's logger class is always going to be installed unless you've done really something interesting to try to make it forget about the logger class. But we're checking here to make sure that you want the logger to be instrumented, and that's one of our configuration options, and that it is in fact defined. And if both of those things are true, we're going to move forward, log a message inside the agent log, and either use module prepending or alias method chaining to go ahead and add the instrumentation code on top of Ruby's method. And so that causes us to have a little bit of a detour into metaprogramming, which metaprogramming can sound really scary. I was terrified of it when I started at New Relic, but it's actually not as bad as you may think. So I won't get into the depths of it today. There are a lot of other great talks at Ruby and RailsConf in the past that have covered this topic. I would also recommend checking out Metaprogramming for Ruby 2 if you want to know more about that. It's written by Paolo Perrotta. But the way that we leverage metaprogramming in the Ruby agent is to stick our instrumentation right before customer's code or right after customer's code to get the timing and the other attributes that we need, and kind of just float on the outside. So hopefully you can't see any performance or other impacts from our agent's observation. So let's see. First, we're going to talk about alias method chaining, and this is an older strategy for metaprogramming. Module prepending is preferred these days. We'll get into that next. But if you're working in a legacy code base, you'll probably come across something like this. I like to think of alias method chaining as going undercover as an agent, or maybe like body snatching. You tell Ruby, hey, you know this method you know about already? We're actually going to give it a different identity. You'll call it by a different name instead, and it'll have slightly different behavior, but like on the inside, it is still the same method. It's still the same identity overall. So here we are taking the original logger class's method, format message, and re-aliasing it as format message without New Relic, and then take our format message with tracing, which is the one that has our instrumentation in it, and wrapping it around the original method. Module prepending is a little different. This isn't code from the agent. This is just an example of what module prepending may look like. And inside of, in this case, we have the logger class, and we would say, hey, we want to prepend our instrumentation class into it. Of course, that doesn't work because we don't necessarily have Ruby's logger inside of our code. So instead, there's other stuff that happens to allow this prepend to work. So then in here, this looks actually pretty simple. We just call the format message method and then take the message with tracing method, which is what has our instrumentation in it, and then call super to make sure it will return to the original higher, basically like parent class that's been defined. So this is actually the bulk of format message with tracing. Right here, we start out by checking to make sure this is something that we actually want to instrument, that an agent is present. And if that's the case, then we will call our log event aggregator and record the message. We also have something you may notice in here, the mark skip instrumenting. We found out that if we tried to record our own events for our own logger, we caused a Stack Overflow because there's just a little too much back and forth going on. So we don't have that yet, but we may someday. Here's the record message method. This is just the first half of it. And what we're looking at here is we're first checking to make sure that this is a viable message to record, both by configuration and by content. And then if you are on the new Relic UI, you'd probably see something like a logs graph on your APM summary homepage, and that's getting populated by this if statement that's in the middle of the record method. The next part is where we actually link it with the transaction. So we look for the current transaction. If that's there, we grab it. We also look for the log priority, which I'll get to in just a second. So if there's a transaction present, we're going to associate the log event to that transaction. If not, we are going to associate it to our separate buffer and still create the event. So the priority, the way that we make sure that the logs associated with the transaction come up first is that we set the priority for the log events to be the same as the transaction's priority. Now, that brings up, why aren't all of the logs? Why do we need a priority at all? Why aren't they all getting sent up? If you create over 10,000 log events in a 60-second time period, logs will get sampled with this feature. You can change that up to as high as 100,000, but what we've found so far for customers is that sampling has not happened or has happened in only really rare cases. So that's just something to keep in mind. But this makes sure that if you have a transaction that's getting recorded, you are going to get the logs all associated with that before you get any logs that aren't associated with a transaction. And then at the bottom, basically we assign a random float that is up to 6 decimal places long as the priority instead, if there is no transaction priority. All right, so here is the rest of that record method. I don't think we needed this slide. And now we are on to creating the actual event. So that was called by both the transaction and the non-transaction sections of that conditional statement. And here is where we get your linking metadata. So at this point in time, we're able to see if it's associated with the transaction, the trace ID, and the span ID that have been grouped with that transaction. And we can also add the priority together. And so this hash, or I guess ultimately array of hashes, is all the log event actually is at the end of the day. And then when we go to actually send it up, we append the linking metadata that's related to your application as a whole. And only the linking metadata that is needed to actually send your log events up and correlate them with your application. So we'll see here that we delete actually an irrelevant attribute that is usually in this payload. So then we create an array of those common attributes and those logs, and that's what gets returned and sent up to New Relic to decorate the UI. So there's the journey from Ruby's logger all the way to the UI. So let's take a look at the UI next. All right, so this is Demotron. This is the account that we usually use for our demos with our customers. And this order composer is a Ruby service that has been updated, not to the latest version of the agent, I see. Okay, we were looking at a different one earlier, but it should still have logs. Let's double check. It does. All right. So once you've upgraded to version 8.7 of the agent or higher, unless you have configured to not collect metrics, you would normally see a chart right here that breaks down your metrics by log severity level. Another place where you can take a look at logs is inside of this triage tab underneath logs. And this will have all of the logs for your particular app right here, from most recent starting at the bottom of the scroll as you go up. Errors inbox is another feature that I personally was really excited about, because now instead of just seeing your stack traces, you get the logs that are associated with that individual stack trace side by side. So you can see what happened before that, that individual method had an error raised. Another place that's pretty exciting is inside of distributed tracing. So we talked earlier about how the trace ID and span ID are associated with the log event. And I believe we should be able to see it on this one. Let's take a look. So if we go to this controller Sinatra purchase, there's a log tab up here. And so this is where you would normally take a look at all of the different spans that occurred inside of that particular request. And you can look at your logs as well. And you can see all of the logs that happened in this request as well. So this is just a brief overview of how that data shows up in the UI. We have ideas for more places that we want to integrate it and hope that you can enjoy them soon. So I want to just tell you really quick about a customer that was part of our early access program. The New York Public Library is a pro bono customer at New Relic, and they joined us and decided to hook up some of their Rails apps to the logger. And what they found was that it actually got them to change the way that they thought about logging on their team. They're now revamping their logs to help make them more meaningful, especially in the cases of common intermittent errors. So one error in particular that they've been facing is that they have a microservice structure and they've been getting failed requests for certain services as they talk to each other, but it hasn't been consistent enough to pin down the errors using the stack trace to any true meaning. And so now they are adding more logs to, they're adding the agent to another one of their apps. They're adding more unique log messages to the services that are having intermittent problems, and they're hoping that this will help them solve these issues to have a better product for their customers. We also have another customer that's been using this product in a very different way. They have a much larger situation. Do you want me to chat about it, or do you want to chat about it, Mike?
I can talk a little bit about it as well. Is that the customer that we've been working with on the APM agent front is Chegg, and if you're not familiar with them, they work in the educational services space, so they provide textbook purchases and rentals for both physical and digital. And there's really two use cases that they identified where they thought that this would be particularly helpful. The first of which is that they wanted to deprecate a series of Fluent D sidecars that they were running in a serverless environment, and so that was going to reduce the amount of toil and cost on their end, since they can just handle the log forwarding and the enrichment through the agent itself. And then the second use case they had identified was kind of reducing their log volume overall, in the sense that one of their goals had always been to exclude low-value log data from collection, but that's extremely challenging in many cases, often time-consuming, and most people don't have the opportunity to do it. But what's interesting is that the APM agent does have that sampling logic in it, where we're prioritizing logs that are associated with transactions, and the amount of logs that we're sampling is completely configurable. So their plan is to use this feature to dial down their log data by about 25%, which is maybe not so good for us, but ultimately we want to make sure that our customers are getting value out of what they're paying for, and this feature is going to allow them to do that.
Thanks, Mike. Yeah, so the last thing that I wanted to tell you all about is the future of the feature, and that's largely dependent on the community. We've already received one feature request to add custom attributes to our log events, and what this particular customer would like to do is allow their container IDs and ECS service IDs to be appended to the log events so that that way when there's problems with individual containers, they're able to more easily troubleshoot them. But I bet there's a lot of other things we can come up with. Maybe filtering by severity, maybe only having particular instances of the logger class or log files getting sent up to New Relic. And we'd love for you to contribute to the New Relic Ruby agent with your ideas and use cases. So as kind of mentioned at the beginning of the talk, the New Relic Ruby agent is open sourced. We accept pull requests and feature requests and bug requests, and would love to know about how you're using the agent and how we can make it better. So yeah, thank you. I just wanted to thank everyone for coming to the talk today. Thanks to Jason Clark, whose wife made this beautiful cape 10 years ago. And he's a major contributor to this feature and also the architect for the logs product. And he was very helpful to making it built. And I'd also like to thank the other lovely people in this audience who have helped me from the beginning of my time as a developer and helped me get all the way here today. So thanks to everyone, and we'd love to open the floor up for a Q&A if you have any questions about how to use this feature or what we talked about today.
I heard you mention that we need to update our agents.
Yeah, yep. So the question was, we mentioned that we needed to upgrade the agents in order to get this feature. Are there other steps that you need to do in order to get it enabled, and will you need to pay more for this feature? So the way that this feature works is that once you upgrade to version 8.7.0 of the agent or higher, log forwarding is enabled by default. So you don't need to change anything in your configuration in order to get your logs sent up to New Relic straight away. If you want to do something like adjust the maximum numbers of samples stored, then you can open up your configuration file or add an environment variable. As far as cost goes, ingest rates do apply. So the same way if you're on the new consumption model, the way it works is that you pay for users and the data that you ingest. And so the first 100 gigabytes of data are always free, and then after that, it becomes more. So that's just how it applies here as well. Does that answer your question? Okay, great. All right, cool. Well, thanks everyone for coming. If you have other questions or just want to talk about something else, feel free to pop up to the front afterwards. And I hope you enjoy the rest of the conference.
Thanks, folks.